Let's take a look at some of the physical properties of metals and nonmetals. So metals bond in this method called metallic bonding. So they bond metallically. So metallic bonding, as it says in the name, metallic, it can only happen within metals. Now what metallic bonding is, I'll go more in depth into this in future videos, but just a brief explanation of metallic bonding would be this. Imagine this is just the universe, and we have protons, right? Protons are positively charged. And remember, the protons are part of the nucleus, so this is the nucleus of atoms. So we currently have 4 atoms, 5, 6, 7, 8. These are atoms, and they're positively charged, right? Now, usually, the electrons would be fixed around one atom, right? So, for example, if something had 7 protons, it's going to have 7 electrons because their number of protons and electrons are the same unless it's charged, right? So what happens is these electrons that are negatively charged, right? These electrons aren't fixed around a single atom. So, for example, there could be a positive proton atom and a negative electron, positive proton, negative electron. So one electron can be attracted to more than one atom. So this is what we call delocalized electrons. So why is it called delocalized electrons? I don't know why. But a fun way that I thought you could use to memorize it is that when one electron is specific, so it has a local area, it's local to one atom, they're localized electrons. When you become delocalized, you're not a localized atom, delocalized electrons. So these electrons aren't local to one specific atom. It moves around, forming bonds with multiple different atoms. Now this allows some specific features of metals to be found. So what some specific properties of metals are due to these delocalized electrons is that they can conduct electricity. So metals can conduct electricity. And why is that? Well, these delocalized electrons allow electrical charges to be carried because these electrons are free to move around, right? They're not stuck around a single atom. So that's why they can conduct electricity. And that's also why nonmetals cannot conduct electricity because the electrons are specific. They're stuck to one specific type of atom. And some other features of metals, we all know this, most metals are shiny. Okay, just look at what do you say? Iron. Is iron shiny? Just metals are shiny. Metals are also sonorous. So what does sonorous mean? Kind of sounds like sonar, right? Sonar radar. So it basically means ringing sound. So these sonar radars emit like pings, right? Ding, ding, ding. If you see some spy movies, you'll see submarines using sonar. So it's a ringing sound when hit, reflecting back. So sonorous just basically means just makes a ringing sound. So when you hit a metal bottle, like this one, this doesn't really work. This makes a ringing sound when hit, right? So it's sonorous. Another feature, metals have high boiling points and melting points. So BP and MP is just an acronym for boiling points and melting points. So these have high boiling points and melting points. Just think about it. You just generally know that metals need very high temperatures to melt, right? Now, why would it have high melting and boiling points? Well, for it to have a high melting and boiling point, you need to have strong bonds between the particles, right? So it means these metals have strong bonds. Why do they have strong bonds? Because these electrons, although these electrons can move around, these atoms, the protons in the nucleus, they're attracted to more than one electron, right? So they form tight bonds together. And this forms a lattice structure eventually. And that's what makes metals strong. So metals are also strong. So this metallic bonding allows metals to be very strong. And that's kind of responsible. So this metallic bonding is responsible for most of their properties, high melting and boiling points, because there's tight bonds. So you need lots of energy to break the bonds. Sonorous, I don't think sonorous is because of metallic bonding, but makes a ringing sound when hit. Shiny, and they conduct electricity because these delocalized electrons are free to move around. I'll make another video in the future about metallic bonding more specifically. Let's take a look at nonmetals now. So nonmetals have a lower density than metals. Lower density. So they have a much lower density. Metals are usually solids, right? Nonmetals, they're usually gases. So look at hydrogen, helium, carbon. They're usually gases. So they weigh less compared to an equal volume of non-metal. So if you had 1 cube centimeter, so like, let's say you have a cube centimeter, where everything's 1 centimeter, and you filled this with metals, and you filled another cube with non-metals, then the non-metal is going to weigh a lot less, because it's not a metal, it's most likely gas. And metals are also non-metals are also brittle. So whilst these metals are strong, I forgot to write that. Metals are strong. Non-metals are brittle. You might not know what the word brittle means, but it's basically the opposite of strong. So it breaks easily. An easy way to think about this is how, you know how your tip of your pencil is made out of carbon? Well, your tip can break if you put a little bit of pressure on it, right? So non-metals can break really easily, so they're quite brittle. They're also poor conductors of electricity, because they do not have delocalized electrons. The electrons are stuck to one specific atom, right? So poor conductors of electricity. So the electrons cannot move around to carry the electrical charge. So they're poor conductors of electricity. And they have low melting and boiling points, because they're not as tightly bonded together, right? These metals are tightly bonded with metallic bonding, but non-metals, they're not as tightly bonded together. So they have low melting and boiling point. Now, what does a low melting point and boiling point mean? It means not so much energy is required to break down their bonds, right? So if you have a low melting and boiling point, they're probably going to be gases at room temperature, whereas metals are going to be solids at room temperature. So non-metals are gases at room temperature. Just look around. You have hydrogen in the air. Everything is gases, right? And lastly, they're quite dull in color. By dull in color, I just mean they're bleak. They're not really shiny. They're not very attractive to look at. So these are some of the metals properties of metals and non-metals.